Section 2.2 is about subsets. When all elements of one set are also elements of another set, the first set is called a subset of the second set. The symbol A with this kind of flattened out C bar underneath that translates as set A is a subset of set B. So subset just means it's a smaller set that's a portion of the bigger set. So let set A equal 1, 2, 3, and let set B equal 1, 2, 3, 4. So we're asking the question, is set A subset of set B? All you have to look at to determine if A is a subset of B is this: is every element in set A also an element of set B? So here's 1, 2, 3, yep, every element of A is an element of set B. Therefore, we would say A is a subset of B. So answering the question, is A a subset of B? Yes. And the symbol for that is A is a subset of B. Is B a subset of A? That would mean that every element of B is also an element of A. Well, we already had our 1 and our 2 and our 3, but set B has 4 and set A does not have 4. So that means B is not a subset, and the way we indicate it is not using the symbol is the symbol with a slash through it. Now we look at a new term called a proper subset. In that last example, the given sets were equal, and they illustrate that every set is a subset of itself. So if we know that set A is a subset of B, and we exclude the possibility of sets being equal like they were on the last example, then set A is called a proper subset of B. That can be a little bit confusing, so I made this little flow chart to help us out here. Before you can answer if a set is a proper subset, you got to just ask, is it a subset? So to be a subset, we know that every element of set A must be a member of set B. So you ask yourself, is every element of set A a member of set B? If the answer to that question is yes, then you can definitely say A is a subset of B. Furthermore, to answer this proper subset question, you have to ask this: is set A equal to set B? If set A is equal to set B, you go no further. If set A is not equal to set B, then you may conclude that A is a proper subset of B. Let's look at some examples to help clear this up. So here's the flow chart again. I have set A 1, 2, 3, 4. I have set B 1, 2, 3, 4, 5. First question, is every element of A also an element of set B? The answer to that here is yes. Therefore, I can say A is a subset of B. Furthermore, I ask, is set A equal to set B? Is set A equal to set B? No. Since I've said no, I may also say that A is a proper subset of B. Second example, set A is 1, 2, 3, set B is 2, 1, 3. Is every element of A also an element of B? Yes, it is. Therefore, I can say A is a subset of B. Then I ask the second question, is set A equal to set B? They are. They're in different order, but they have the same exact elements. So set A is equal to set B, and that's where we can go no further. So this is the instance where we're allowed to use both symbols. This is where we can only use the subset symbol. One little thing that you can do that might help you out also is to think about the number of elements. If the number of elements in both sets is the same, then you cannot use the proper subset symbol. On the other hand, if one set has less elements than the other, you can use the proper subset symbol. So a couple more examples. If things are given to you in set builder notation, if it helps you, change it to roster form. So set A is all X such that X is a person and X lives in San Francisco. Set B is all X such that X is a person and X lives in California. So if you live in San Francisco, do you live in California? The answer is yes. So is every element of A an element of B? That's yes. So I can say A is a subset of B. Then I have to ask the question, is set A equal to set B? No, there's a bunch more people who live in California than live in San Francisco. Since set A is not equal to set B, I can also use the proper subset symbol. Second example, set A is 2, 4, 6, 8. Set B is 2, 8, 4, 6. First question, is every element of A an element of B? The answer is yes, and I can say A is a subset of B, but I have the fact that set A equals set B. If set A equals set B, then I cannot use the proper subset symbol. This is a MathXL question. It's asking you to determine whether you can use the subset symbol, the proper subset, both, or neither in the blank. So this is in set builder notation. So x is an element of the naturals, and x is between 0 and 3. So the numbers, the natural numbers that are between 0 and 3 are 1 and 2. Remember, plain old less, you're not going to use the 0, you're not going to use the 3. This in words says the set of all natural numbers between 0 and 3, which is 1 and 2. So first question, is every element of this set a member of this set? And the answer is yes. So I can definitely use the subset symbol. Second question, is set A equal to set B? Yes, it is. That means I cannot use the proper subset symbol. So our answer would have to be B. All right, something to clarify here that you might be confused on. There's two symbols that look similar and have sort of a similar meaning, and that is element and subset. 4 is an element of the set, looks like this. Notice 4 does not have any kind of brackets around it. 4 is just an element, E for element, of this set 4, 8. This is a little different terminology. The set that contains 4 is a subset of the set, just like this. The set that contains 4 is a subset of the set that contains 4 and 8. So you got to be careful. Look carefully when you're doing your homework problems. So can I say 4 is a subset of 4, 5, 6? No. If you're using that symbol, you better have brackets around the 4. So this is false. Is the set that contains 3 an element of the set that contains 3, 6, 8? No. We cannot use the element symbol if you're talking about set. Now this one looks kind of tricky. This is this 5, the set that contains 5. Is it an element of this set that contains 2, 5? And the answer is yes. I know that looks tricky because of the brackets around 5. Pretend for a second it had been 5 in a triangle. Is an element of 2 inside a triangle, comma, 5 inside a triangle. So can we use the element symbol there? Yes, we can. So kind of pretend that's like a sign or a picture or something, and it is an element of that set. The empty set is also a subset. It may sound kind of weird to you, but for any set B, the empty set is a subset of B. And for any set other than the empty set is a proper subset of B. This means that the empty set is a subset of every set, and furthermore, the empty set is a proper subset of every set except itself. What that's talking about is this. If I gave you a true-false question and said the empty set is a proper subset of the empty set, you would have to say false. We will also have to count the number of subsets. So notice this little chart. This has got no elements, 1 element, 2 element, 3 elements. So if I were to actually make a list of the subsets of the empty set, it's just that. The only subset of the empty set is the subset, is the empty set itself. So it has 1 subset. If I have a set that just contains 1 element, one of the subsets is the set itself, and one of the subsets is the empty set. How many is this? It's 2. When there are 2 elements, my subsets are the single set A, the singleton set B, the set itself, which is AB, and of course the empty set, which gives me 4. To write out all the subsets of the set that contains ABC, I have the singleton A, the singleton B, the singleton C. Then look at your doubles. You have A matched with B, you have A with C, you have B with C, then you have the set itself, and of course the empty set, and that's 8. Do you notice anything about these numbers? 1, 2, 4, 8. Hopefully you notice that they are powers of 2. The number of distinct subsets of a set with n elements is 2 to the n. The number of proper subsets is 2 to the n minus 1. The reason we have to subtract 1 to find the number of proper subsets is because every subset except itself is a proper subset. So let's find the number of distinct subsets and the number of distinct proper subsets for each set. The number of, that does not mean we have to make this big huge list. The number says we're going to use the formula, 2 to the n. What's our n? Our n refers to the number of elements. There are 5 elements in this set, so this is 2 to the 5th, which is 32. You can use your calculator if you need to. The proper subsets, just a matter of subtracting 1 from 32, which is 31. Same kind of question, but this is in set builder notation. This was supposed to have a little element here. So this is x is an element of the naturals, and x is between 9 and 15, including the 9 and 15. You might want to make a list. So it's 9, 10, 11, 12, 13, 14, 15. So that's how many elements there are in that set, and that's 1, 2, 3, 4, 5, 6, 7. So our number of subsets is 2 to the 7th, which is 128. And the number of proper subsets would be 1 less than that, which is 127. And again, the reason we are subtracting 1 to get the proper subsets is the subset 9, 10, 11, 12, 13, 14, 15 is equal to the original set of 9, 10, 11, 12, 13, 14, 15. So we must exclude it from our list of proper subsets. A couple little facts about subsets. Every set is a subset of itself. The empty set is a subset of every set. The empty set is a proper subset of every set except itself. I showed you that a couple of screens ago. And here's our formulas. The number of subsets of a set with n elements is 2 to the n, and the number of proper subsets of a set with n elements is 2 to the n minus 1.